Hi, welcome. We're going to teach you how to do a statics problem. So the givens that we know are 60 degrees and 30 degrees are the measurements of these inner angles. The weight of the mass is 15 newtons as well. So in trigonometry, we know that cosine is adjacent, so this one, over hypotenuse, which is this one. Therefore, this equals T1 times cosine 60, and this one is T2 cosine 30. And then we know that the sine equals opposite over hypotenuse. So therefore, this is T1 sine 60, and this is T2 sine 30. So in physics, the up forces must equal the down forces, and the left forces must equal the right forces. So we know that the up forces, which is T1 sine 60 and T2 sine 60, must equal the down forces, which is 15 newtons. So that equation can be written as T1 sine 60 plus T2 sine 30 equals 15 newtons. And then because we know that the left forces equal the right forces, that is written as T1 cosine 60 equals T2 cosine 30. And with these two equations, we will be able to figure out both T1 and T2.
So using this system, we can solve for both T1 and T2, but first we have to isolate one of the variables. So we can say T1 equals T2 cosine 30 degrees over cosine 60 degrees. Now we can substitute this in for T1 in the first equation by saying T2 cosine 30 times sine 60 over cosine 60 from right here plus T2 sine 30 degrees equals 15. So now we only have one variable in this equation and can solve it using algebra. So since we know the values for cosine 30, cosine 60, sine 60, and sine 30, we can say that 1.5 T2 plus 0.5 T2 equals 15. Therefore, 2 T2 equals 15, and tension 2 equals 7.5. Now, to solve for T1, we just simply plug this back into here. So T1 equals 7.5 cosine 30 over cosine 60. So now we know that T2 equals 7.5 newtons, and from solving this, we can say that T1 equals 12.99 newtons. And there is the solution to our statics problem. So this next problem is still a statics problem, but it's a little bit different because we're given the tensions and not the mass. So since we know that these two equal 10 and 5, like before, we can say that this equals T2 sine 30, but really this is 5, so it's 5 sine 30. And this one is T1 sine 60, but we know that that is 10 sine 60. And now we can say 10 sine 60 plus 5 sine 30, which are the up forces, equals the down force, which is the unknown mass. And by solving these two, we can say that mass equals 11.16 newtons.
Here's a model of what we just did. This pair of keys is the 15 Newton weight, and then this is tension 1 and tension 2 with 60 degrees right here and 30 degrees right here. As you can see, the tension in tension 1 is much stronger than the tension in tension 2. If you adjust the angles, it's easy to see that the tension has now been altered. Therefore, the tensions have a great amount to do with the angle of the string.